Welcome to Sanjay Vadat, IIT and Medical Academy. My name is Uday Shankar. Today I am going to discuss kinematics. In kinematics, calculus-based problems. So first of all, if we have displacement, that means body is going from this one to this point. It has displacement. Now it has a variable velocity. Now I want to find out in a particular instant velocity I want to find out, because this body velocity is gradually changing. Either it may increase or decrease. At a particular point, instantaneous velocity means at this particular time we have to find out the velocity. For that, at particular time you can't find out. We have to allow some small distance dx. We have to allow the body to travel small distance dx, and dx means ds, displacement, in a time dt. This time interval is dt. This dt should be very, very small. In this particular small time interval, the displacement of the body is ds. Then at that time velocity is instantaneous velocity. That instantaneous velocity is equal to ds by dt. That means differentiation of displacement gives velocity at that instant. At that instant. Suppose body is travelled from this one to this point. Now, if you want displacement, then ds can be calculated. ds is equal to v dt. Suppose you have to do the integration, both sides. Suppose this time is t1. At that time I am counting the displacement, that is 0. That time is t1. Now it comes to this point and this time is t2. At that time this displacement is s. Then integral of ds is s. Integration limits 0 to s is equal to integral of v dt. That integration limits are t1 to t2. Then s is equal to displacement if you want to find out v dt. So, displacement is given, velocity, instantaneous velocity is ds by dt. Velocity is given, displacement, integration. Here we have to do differentiation. For velocity, we have to do the differentiation of the displacement. For displacement, we have to do the integration of the velocity, v dt. Suppose average velocity, this is instantaneous velocity. If you want to find out the average velocity, total displacement by total time. Total displacement by total time, that is equal to integral of v dt. Integration is limits are t1 to t2 by this time is dt. dt integration is t1 to t2. T is integral of dt is t. That limits are t1 to t2. Then you will get the average velocity. This is instantaneous velocity. At any time we can find out the velocity. Average from this time to this time, average velocity if you want to find out, total displacement by total time you have to find out. Similarly, if velocity is given, instantaneous acceleration to find out, a is equal to dv by dt. For example, body is moving from this point, here velocity is v1, here velocity is v2. Gradually, suppose velocity is increasing. velocity is increasing. Now at this instant, change in the velocity is dv in small in time interval dt, then acceleration is equal to, at that time, acceleration is dv by dt. dt is very, very small. If time interval is very, very small, here you will get the accurate value of acceleration at that instant. Now, once you know the acceleration dv by dt, then if you want to find out dv a into dt, integration you have to do. That v1, initially here velocity is v1 at time t1. Velocity is v2 at time t2. Then dv integration is what you are getting now? V. dv integration is equal to v. Limits you have to apply. v1 to v2 is equal to integral of a dt. Integration limits are t1 to t2. Then you will get v2 minus v1 is equal to integral of a dt. Integration limits are t1 to t2. Okay. So in this way, we can find out, see, velocity differentiation of displacement. Displacement, integration of velocity. Acceleration, differentiation of velocity. Velocity, suppose v1 is given, v2 can be calculated. Velocity at any time t2, v2 you have to do the integration of acceleration. One more thing we can write, acceleration is equal to dv by dt. We can write dv by ds into ds by dt. So acceleration is equal to ds by dt is, you can write ds is cancelled, dv by dt you will get. So acceleration is equal to ds by dt is velocity into dv by ds. So we have acceleration as two formulae. One, if acceleration depends on time, velocity depends on time. You have to use this formula. Acceleration is equal to dv by dt. If velocity is function of displacement, acceleration is equal to ds by dt is velocity into dv by ds. In this way also you can find out the acceleration. So that I am writing displacement to get velocity differentiation. Velocity differentiation gives acceleration. Acceleration integration gives velocity. Velocity integration is displacement. What we discussed, displacement differentiation gives velocity. V is equal to ds by dt. Velocity differentiation gives acceleration, dv by dt. Acceleration integration gives velocity. For short. Actually v2 minus v1, t1 to t2 you have to write. Velocity integration, displacement. One more thing, acceleration has one formula dv by dt, one more formula v into dv by ds. These are the main points you have to remember in the calculus based problems. See, I am giving one example. The displacement x is equal to t square plus 2t plus 1. Find the velocity at t equal to 2 seconds and acceleration at t equal to 4 seconds. If you do differentiation of displacement, displacement is given t square plus 12t plus 1. If you do the differentiation, dx by dt, differentiation of this one, 2t plus 12. Now, this is velocity depends on time. At what time you want? At t equal to 2 seconds. So, if you substitute t equal to 2 seconds, then that you will get 4 plus 12, 16 meters per second. Now, velocity differentiation gives acceleration. We have velocity is what? What is the velocity? 2t plus 12. For this one differentiation 2. T is equal to 1. Differentiation of t is 1. 12 differentiation 0. Acceleration is 2. 2 means it is independent of time. That means it is uniform acceleration. Uniform acceleration. Suppose it is given displacement is in meters, you will get meters per second square. Displacement is given centimeters, centimeters per second square. Uniform. At t equal to 4 seconds, ये 2 आता है. At t equal to 5 seconds, ये 2 आता है. At t equal to 3 seconds, also 2 you will get. So, this is uniformly accelerated body. Velocity is linearly increasing, then acceleration is uniform. Now, acceleration is given. Initially, body starts from rest. Find the velocity at t equal to 2 seconds. Acceleration, reverse process. Displacement to velocity differentiation, velocity to acceleration differentiation. Acceleration to velocity integration. Integration you have to do. How, what way you can do? To find out the velocity, dv integration is equal to a dt integration. Initially, body starts from rest. Initial means time 0. Velocity is 0. Starts from rest. Suppose it is velocity 1 meter per second is given, you have to write that one. Now, velocity at t equal to 2 seconds. At 2 seconds, what is the velocity? What is the velocity? I am applying the integration limits. So, dv integration is v. Limits apply kiya to 0 to v. ये value 2t plus 5 integration you have to do dt. You will get 0 to 2. So, v minus 0 is equal to 2t square by 2 plus 5t you will get. That means velocity is equal to what you will get? So, 0 to 2. Velocity you are getting t square plus 5t. This is velocity. But we have to apply the limits. Because where you have to find out at t equal to 2 seconds. Velocity you have to find out. So, limits you have to apply. A velocity you know. So, v minus 0. I am applying the limits 0 to 2. 0 to 2. So, velocity is equal to. So, I got that 2 square plus 5 into 2 minus 0 minus 0. You will get that. So, this is equal to 4 plus 10. So, you will get that velocity is equal to 14 meters per second. Okay. Similarly, initial displacement of the body is 0, then find the displacement t equal to 3 seconds. You know this is the velocity. This is velocity as function of t. Here limits is after applying limits, you will get velocity value. But initially without applying limits, this is the velocity. Now velocity you have to do the integration. Displacement ds is equal to v dt. Integration limits you have to apply 0 to s. Initially 0, displacement is 0, at a time 0, now at a time t. T is equal to 3 seconds. Now ds integration is s, limits apply किया तो s minus 0 is equal to v integration t square plus phi t dt integration 0 to 3. So s is equal to t cube by 3 plus phi t square by 2. Then you have to apply these limits, upper limit minus lower limit. You will get the displacement. So reverse process. Just 3 cube by 3 plus phi 3 square by 2 minus 0. You will get the displacement at t equal to 3 seconds. So same thing we applied. Displacement 0 to t, t cube by 3 plus phi t square by 2. Yeah, t equal to 3 substitute karo. Then 3 cube by 3 plus phi 3 square by 2. You will get 9 plus 22.5. This is 31.5. Now, the motion of an object along the x-axis, the velocity v depends on displacement x as v equal to 3x square minus 2x. Find the acceleration at x is equal to 2 meters. You know, acceleration is equal to, it is function of displacement, then acceleration formula v into dv by dx. That is the acceleration formula. Acceleration has two formulae, dv by dt. If v is function of time, you have to use that. And if v is function of displacement, you have to use this function, this formula. So, v value is 3x square minus 2x. I wrote the v value into dv by dx. dv by dx, its differentiation is 6x minus 2. Now I am substituting 3 into 2 square minus 2 into 2, 6 into x value is 2 minus 2. So acceleration is equal to 3 into 4 minus 4 into 4 more 12 minus 2. So A is equal to 12 minus 4 into 12 minus 2. So 8 into 10, 80 meters per second square. Just I am using the formula V into dV by dx. Just I applied that formula. So dV by dx means it's a differentiation. Then I substituted x is equal to 2. Now, the velocity of the particle is given. If its position at x is equal to 0, at t is equal to 0, then its displacement after unit time, that means t is equal to 1 second. So, velocity is given, displacement, reverse process. Velocity is given, displacement is, you know that displacement ds by dt is velocity. ds by dt is velocity. Now, ds you want to find out v dt. Integration limits 0 to s is 0 to t, because these conditions are given, x is equal to 0 at t equal to 0. Then at t, this displacement is s. So, ds 0 to s is equal to 0 to t. This I wrote is equal to v naught plus gt plus ft square dt. Integration limits. First integration you have to do v naught dt, v naught t. v naught dt integration is v naught t. gt dt integration gt square by 2. ft square dt integration ft cube by 3. Now substitute t is equal to 1 second. then you will get the displacement. Here you have to substitute t is equal to 1, you will get the displacement. Suppose the coordinates of a moving particle at any time t is given as x is equal to alpha t cube and y is equal to beta t cube. That means it is not moving along one direction, it is moving in a plane. It is here, it is here, it is here. It has a x coordinate and it has a y coordinate. X depends on time as alpha t cube, y depends on time as beta t cube. Alpha t cube, beta t cube. Now, velocity, the speed of the particle. Speed is nothing but magnitude of velocity. Speed is nothing but magnitude of velocity. Am I right? Because it is going in a straight line, speed is nothing but magnitude of velocity. So, first Vx, along x direction velocity we are calculating that Vx is equal to 3 alpha t square. Vy is equal to 3 beta t square. Once you know Vx and Vy, in vectors you know that horizontal component, vertical component if you know, velocity is nothing but Vxi, velocity is nothing but Vxi cap plus Vy j cap. I am writing that one. Vxi cap 3 alpha t square I cap, Vy j cap 3 beta t square j cap. What is magnitude? Because magnitude is the speed. So, you have to find out the magnitude, that is 3t square बाहर लेके गया तो 3t square. So, alpha square plus beta square. Suppose a particle is moving along the path given by y is equal to c t power 6 by 6. Find the relation between acceleration a and velocity v of the particle at t equal to 5 seconds. Velocity. How you can find out the velocity? You have to do the differentiation. That is nothing but 6c t power 5. Differentiation 6c t power 5 by 6. You are getting c t power 5. Well, now one more time, if you differentiate the velocity dv by dt, that is velocity c t power 5, you will get the acceleration. C t power 5 means 5 c t power 4. You will get the acceleration. Velocity by acceleration. C t power 5 by 5 c t power 4, that is t by 5. Now put t equal to 5 seconds. Put t equal to 5 seconds, v by a is equal to 5 by 5, because we want to find out the relation at t equal to 5 seconds. You have to write, put t equal to 5 seconds, this is 1, v is equal to a, you will get velocity is equal to acceleration. The displacement of the body is 3s is equal to a plus 4b t cube. Find the velocity of the body at the end of 1 second. So, displacement s is equal to a by 3 plus 4b t cube by 3. Now, you have to do the differentiation. Velocity is equal to ds by dt, that is, it is a constant differentiation is 0. Plus 4 by 3 bt cube differentiation is 3bt square Then this 3 will cancel, 4bt square. T is equal to 1 second, t equal to 1 second, v is equal to 4b into 1 square, that is equal to 4b. The displacement x of a particle moving in one direction reaction under the action of a constant force is related to be time by equation, whatever it may be. Final time and displacement relation is given. He is saying something, but displacement x, time t relation is given. Where x is in meters, t is in seconds. Find the displacement when velocity is 0. Find the displacement when velocity is 0. So, velocity you have to find out and make it 0, then time you will get. So, first time is equal to root x plus 3. Root x is equal to t minus 3. X is equal to t minus 3 whole square, squaring both sides. So, x is equal to t square plus 9 minus 60. Differentiation dx by dt. So, differentiation of t square plus 9 minus 60. So, velocity 0 is equal to d by dt. This is 2t minus 6. So, time when velocity is 0 is what? Time when velocity is 0, 2t is equal to velocity is 0, that time t you have to find out. 2t is equal to 6, t is equal to 3 seconds. Now, at that time displacement you want. At that time displacement you want. So, you are writing in this formula 3 square plus 9 minus 6 into 3. So, 9 plus 9 minus 18. So, displacement is 0. Displacement is 0. A particle having velocity v equal to v naught at t equal to 0. Initially its velocity is v equal to v naught at t equal to 0. It is decelerated at a rate beta root v, where beta is constant. After what time the particle comes to rest? After what time the particle comes to rest? Decelerated. Only deceleration magnitude is given, but magnitude of deceleration is beta root v. Deceleration meaning minus negative acceleration. Minus acceleration is dv by dt. Deceleration is negative acceleration. Beta root v. Take root v this side, dt this side, minus as it is. dv by root v. dv by root v is equal to minus dv by root v is equal to beta dt. So, root v means v power minus 1 by 2 dv is equal to a minus I took this side, beta integral, beta is a constant into dt. Limits, we are doing integration now. Integration. So, initially velocity is v naught at a time 0. I have to apply the limits v naught at a time 0, at a time t velocity is v, I have to find out that. So, v naught to v, dv is root v means v power minus 1 by 2 dv, that is equal to take minus to this side minus beta dt. Integration limits v power minus 1 by 2 plus 1 by minus 1 by 2 plus 1. I did first integration. V power minus 1 by 2 plus n plus 1 by x power n plus 1 by n plus 1. Limits V0 to V is equal to minus beta dt integration t 0 to t. Then V power 1 by 2 by 1 by 2. Limits are V0 to V is equal to minus beta t. So, 2 root V, V0 to V is equal to minus beta t. So, 2 root V upper limit minus 2 root V0 is equal to minus beta t. Now, time the particle comes to rest. So, what is the velocity now? Velocity should be equal to 0. Velocity should be 0. Comes to rest. Comes to rest means velocity is 0. Minus 2 root V0 is equal to minus beta into t. So, this time you have to find out. So, then you will get that 2 root V0 is equal to beta t. So, t is equal to 2 by beta into root V0. So, same thing we did. So, t is equal to 2 root V value 0 minus root V0 by minus b. So, 2 0 minus root V0 by minus b, minus minus will cancel. Time is equal to 2 root V0 by b. Position of a particle varies with time as, position means displacement, at square minus bt cube. Find the time when acceleration is 0. Position means displacement. Displacement is at square minus bt cube. Once differentiation, velocity. That velocity is equal to 2at minus 3bt square. One more differentiation of velocity, acceleration. Acceleration. For this one, acceleration, I am writing that a, because already small a here used, so I am writing that is a. So, for this one, differentiation 2a minus 6bt. This is the acceleration. Acceleration is 0. Acceleration, what we got? 2a minus 6bt. So, acceleration 0 is equal to 2a minus 6bt. So, 2a is equal to 6bt. Time is equal to 2a by 6b. So, a by 3b. A particle moves along x-axis in such a way that x is equal to 2 minus 5t plus 6t square meters. Find its initial velocity. Initial velocity means time 0, what is the velocity? Time is 0, what is the velocity? So, velocity is equal to, you can write dx by dt. V is equal to dx by dt. D by dt of 2 minus 5t plus 6t square. So, for this one, 2 differentiation 0, 6t square differentiation 12t minus 5t differentiation minus 5. Initial means t is equal to 0. If t is equal to 0, if you substitute 12, t is equal to 0 minus 5, that is equal to minus 5 meters per second. We know that already I discussed that how to get average velocity. Average velocity is nothing but total displacement by total time. Total displacement, how you will get? ds by dt is v, then ds is equal to v dt. So ds 0 to s is equal to v dt 0 to t. So ds integration is s 0 to s v dt integration 0 to t. So s is equal to integral of v dt 0 to t. Integral of dt 0 to t is t, because integration is t, limits apply after application of limits capital T. So average velocity is total displacement by total time. Total displacement is nothing but integral of v dt 0 to t by integral of dt integration 0 to t. Integral of dt gives time, total time. Integral of v dt 0 to t gives total displacement. So average velocity is nothing but total displacement by total time. Find the average velocity during third second if displacement is given. Third second. Average velocity. Third second means you have to remember 0 to 1 first second. 1 to 2 second. 2 to 3 third second. So 2 to 3 you have to take the integration. So 2 to 3 v dt, 2 to 3 dt. So v value is, how you will get the v value? Displacement differentiation, alpha plus beta t plus gamma t square. Displacement differentiation is velocity. Beta, alpha differentiation 0, beta t differentiation beta, gamma t square differentiation 2 gamma t. 2 gamma t plus beta dt. to dt इंटीग्रेशन किया तो t 2 to 3. We got v. I am substituting v value here. dt integration is t 2 to 3. Now I have to do the integration of this one. Integration of this one is equal to 2 gamma t square by 2 plus beta dt integration beta t 3 minus 2. So then 2 will cancel. Upper limit you have to write gamma 3 square plus beta 3 minus gamma 2 square plus beta 2. So 9 gamma plus 3 beta minus 4 gamma plus 2 beta. So 5 gamma plus beta. This is the average velocity. Average acceleration. Average acceleration means velocity to average acceleration is integral of a dt, because average velocity integral of v dt if you get, average acceleration integral of a dt by integral of dt from t1 to t2. Average acceleration. So S is equal to 10t plus 20t minus 5t square. Find the displacement in 1 second. Find the distance in 3 seconds. Find initial acceleration. Find velocity in 4 seconds. Find average velocity in 2 seconds. Find average speed in 3 seconds. Everything, all calculus based sums are given in here. So I am calculating. See, S is 10t plus 20t minus 5t square. Displacement in 1 second. 1 second substitute. I got the displacement. If it is in meters, it is meters. If it is centimeters, it is centimeters. Distance in 3 seconds. Distance is, you have to, easily you can't write t equal to 3 seconds. This is displacement. Sometimes what happened, body will go forward and comes to rest, and after that it return back. If you substitute t equal to 3 seconds, this gives this displacement. You will not get the distance. So for that, to find out the distance, first you have to find out the velocity. What is the velocity? For this one differentiation, you will get that actually this is 10t plus 20t, that is nothing but 30t. So displacement is 30t minus 5t square. So velocity is differentiation of displacement ds by dt, that is 30 minus 10t. Now I got the velocity. At t equal to 3 seconds, so velocity is equal to 30 minus 10t. At what time velocity 0? That is 30 minus 10t. So velocity is 0, 30, and t is equal to 30 by 10, that is 3 seconds. At 3 seconds only velocity is 0. So they are asking distance in 3 seconds. So distance in 3 seconds, no problem. It goes this straight line. So displacement is distance. Then S is equal to distance because it goes this straight line only. So that is 30 into 3 minus 5 into 3 square. Directly you can write. Suppose they are asking at t equal to 4 seconds distance. Then you have to do distance v dt from 0 to 3 magnitude plus v dt 3 to 4 magnitude. Here negative value you will get. But if you take magnitude, you will get the plus value. Here also plus value. So total displacement distance you will get. At t equal to 3 seconds, no problem. At t equal to 4 seconds, it will reverse back. If you directly write 4 seconds, you will get the displacement only. This value you will get. To find out this distance, first this distance I calculated. Next this distance. If they are asking distance at 4 seconds. Now, find the initial acceleration. Velocity I know. Velocity is equal to 30 minus 10t. Differentiation. Acceleration is equal to 30 differentiation 0 minus 10 t differentiation 1. So, acceleration is minus 10. A fixed I. Minus 10. If meters per second meters is given, this is meters is given, then meters per second square. It is fixed. Constant. It is independent of time. So, acceleration is always minus 10 meters per second square. There is no need of initial, final, because always constant. Find the velocity in 4 seconds. Velocity in 4 seconds means differentiation displacement. Velocity I got 30 minus 10t. So, velocity is 30 minus 10 into 4. So, velocity is equal to minus 10. That means, after 3 seconds, 1 more second it returned back. That's why we got the minus sign. Find the average speed in 3 seconds. Average speed in 3 seconds means total distance in 3 seconds. Total distance in the 3 seconds is this one. By total time 3 seconds. Average speed means this. What is the total distance in 3 seconds? 90 minus 45. 90 minus 45. So, average speed in 3 seconds is nothing but average speed in this total displacement 45 by 3. So, 45 by 3 is 15 meters per second. If it is given in meters or centimeters per second when centimeters is given. So, every problem we discussed the calculus, all problems are discussed in this problem. So, everything I discussed this one. Average velocity is total displacement, everything I discussed. Next. A point moves in a straight line so that its displacement and time are related. X square is equal to 1 plus t square. Find the acceleration at a time t. First, I am taking displacement x square is 1 plus t square. I am doing the differentiation. D of x square is equal to 1 plus d of differentiation of 1 plus t square. X square differentiation 2x. You have to write dx here. I am doing the difference, meaning is that I am doing the differentiation of x. Differentiation of 1, 0. T square differentiation 2t. I have to write dt. I have to write dt. Here I am writing differentiation of x, so dx. I am writing dt. Then 2 will cancel. So dx by dt is equal to t by x. That is velocity is equal to t by x. Velocity is t by x. So, Vx is t. Differentiating again both sides because we want to get the acceleration. Again differentiation. Differentiation of Vx, differentiation of t. Then here V and X are both are variables. So, you have to use product rule. Product rule is what? V, x ka differentiation 1, dx you have to write. Plus x, v ka differentiation 1, I am doing differentiation of v, that's why dv. Differentiation of time is 1 dt. So, v dx plus x dv is dt. Now, v dx by dt plus x dv by dt is, I am dividing with dt. I will get 1. I am dividing total with dt. Dx by dt is again velocity. So, v dx by dt is velocity plus x dv by dt is acceleration. Acceleration is a is equal to 1. So, xa is equal to 1 minus v square. So, acceleration is equal to 1 minus v square by x. But in our problem, v is not there. V is not there. So, you have to replace the v. V is already we wrote t by x. I am writing that 1 minus t by x whole square by x. So, a is equal to x square minus t square by x square here by x cube, x cube. But x square minus t square from first equation, x square minus t square is 1 by x cube, So, you will get that acceleration is equal to 1 by x cube. Here I am using that dx square, in this way we are doing x square differentiation. I have to write that I am doing the differentiation of x. I am doing the differentiation of x, you have to write dx. Here t square difference 2t, you have to write I am doing the differentiation of t. Here also I am doing the differentiation of x, I am writing x differentiation 1 dx. Here I am doing differentiation of v, so v differentiation dv, x into v differentiation 1 v differentiation 1 into dv, t differentiation 1 into dt. So everything again I calculated and I got that 1 by x cube. One more relation. The relation between time t and distance x as t equal to ax square plus bx, where a and b are constants. This is given in 2025 NEET problem. The acceleration is. Now, first you take this one, t is equal to ax square plus bx. Both sides differentiation. T differentiation 1, no, dt you have to write, I am doing differentiation of t. Here a, x square differentiation 2x, you have to write dx. B, x differentiation 1, no, dx, I am doing differentiation of x. So, I got that dt equal to 2ax dx plus b dx. Divide with dt. Divide with dt. dt by dt is 1. 2ax. dx by dt is velocity. B. dx by dt is velocity. So, I got that 1 is equal to, v is taken as common, 2ax plus b. So, I got that v is equal to 1 by 2ax plus b, but I want acceleration. Again, I am taking this one, this term. Again, I am taking that term. So, that term is, what is that term? 2a, 1 is equal to 2axv plus bv. 1 is equal to 2axv plus bv. Now, again differentiation, 1 differentiation 0, 2a, again these x and v are both are variables. You have to use the product rule, x you have to place here, v differentiation 1, dv, I am doing differentiation of v, plus v and x differentiation 1, I have to write dx, plus b, v differentiation 1, dv. So, 0 is equal to 2a x dv plus v dx plus b dv. But acceleration to find out, what we have to do? You have to divide with dt. 0 by dt is equal to 2a x dv by dt plus v dx by dt plus b dv by dt. So 0 is equal to 2a ax into acceleration plus v. Dx by dt is the velocity v square plus b into acceleration. Acceleration I am representing with capital A. Then 0 is equal to, I am taking a is common, 2ax plus b into acceleration in these two terms plus 2a into v square. So, I want to find out the acceleration. Take this one to that side, minus 2ax plus b into a is equal to 2a v square. So, I got this one, 2a v square. So, acceleration is equal to minus 2a v square by 2ax plus b. 2a v square by 2ax plus b. We got this acceleration, minus 2a v square by 2ax plus b. This is the acceleration. Thank you.